Imagine a daybreak that encompasses half of the sky in the distance. NASA has provided images of a previously unseen anomaly in which a star called Betelgeuse went crazy, sending a massive chunk of its surface mass hurtling into space. According to the space agency, the event, which is called a surface mass ejection, was 400 times as massive as a typical solar flare from our Sun. When a star removes such massive chunks of its physical structure, researchers say they are witnessing cosmic growth in real time. Surprisingly, a lot of what we know about the cosmos is being disturbed by this very crimson monster's catastrophic detonation. How might the universe have been affected by Betelgeuse's insanity? Let's sort things out. Numerous stars make up the heavenly bodies, which are still utilized for navigation today and are arranged in accordance with myth and tradition. Betelgeuse, one of the largest and brightest stars in our night sky, is one example of this. The upper right shoulder of the winter constellation Orion, the Hunter, is home to the beautiful ruby-red dazzling star known as Betelgeuse. Observed with awareness, stargazers see it as a raging monster with a heartbeat of regular throbs that lasts for several days. Betelgeuse's unsettling orange-red hue makes it easy to identify. It's perfect for convincing skeptics that stars do, in fact, have different tones. After the blue supergiant Rigel, it is the second most bright star in the constellation and is also referred to as Alpha Orionis. Because of its peculiar name and fluctuating character, Betelgeuse is an intriguing object for star studies and observations. Although Rigel, Orion's other magnificent star, is brighter. Stars with the name Alpha are typically the brightest stars in their constellations. Because of its name, brightness, size, and ruddy tinge, Betelgeuse is Alpha Orionis, and it is arguably one of the most prominent stars. This star's role as the model for the character in the movie Betelgeuse makes it noteworthy. The star is the 10th brightest star in the sky overall and the 7th brightest star that can be seen from most of North America, Europe, and Canada. The distance between Earth and Betelgeuse is thought to be between 430 and 724 light-years, although space professionals are unable to determine the precise distance. The reddest supergiant star in our galaxy, Betelgeuse, is the nearest to Earth. Only 200 red supergiant stars have been found so far. The radius of the Sun is approximately 764 times greater than that of Betelgeuse. The star would stretch past the asteroid belt and even past Jupiter if it were to take the place of our Sun in the solar system, implying that Earth, Mars, Venus, and Mercury would all be fully consumed. Betelgeuse may be seen from 548 light-years away and has 12 to 26,000 solar radiances, making it several times as large as the Sun. This star is colder than the Sun, with a surface temperature of about 3,600 Kelvin. Appearance of light accounts for around 13.3% of Betelgeuse's bright energy. Betelgeuse would overtake Sirius as the brightest star in the night sky if the human eye could detect light at all frequencies. Every 1,500 years, Betelgeuse loses about 1 solar mass. Because of the unequal outflow of material from the star in all directions, the red star is encircled by a cloud. Betelgeuse is surrounded by a cloud of material several times larger than the star. This cloud is also estimated to be 30 galactic units in size, which is several times the distance from the Sun. This distance separates the Sun from the solar system's furthest planet, Neptune. Solar flares are the continual mass launches from our solar system's Sun into space. However, the occurrence is called coronal mass ejection, CME, because the Sun only exhales small portions of its outer atmosphere, known as the corona. Consequently, surface mass ejections and coronal mass ejections may occur at different periods. The corona CME is created when a star releases a portion of its unstable outer atmosphere. Earth and its population may be impacted by the periodic coronal mass ejections from our solar system. CMEs can shoot plasma and magnetic fields into space at speeds of over 1,800 meters per second, and they can occasionally show up on Earth in a matter of hours. When a CME occurs on the side of the Sun that faces Earth, it has the potential to interfere with and harm the planet's power systems and satellites. It also occasionally puts astronauts in orbit at risk. The novel finding clarifies the peculiar reason behind Betelgeuse's transformations. The material that the star ejected in 2019 exploded into space, cooled, and formed a massive dust cloud that blocked Earth-based astronomers' view of Betelgeuse's brightness. Additionally, the renowned, steady beating pattern of Betelgeuse has changed. The star shuddered like a bowl of gelatin treats due to the unexpected CME on Betelgeuse, which expelled 400 billion times more mass than a typical CME. The star's photosphere, or star surface, is having trouble reproducing itself, and its internal convection cells may be in disarray, said Andrea Dupree, a space expert at the Center for Astrophysics, in a NASA news release. For the past 200 years, cosmologists have been monitoring the star's steady pattern, but it is no longer there. Experts will be able to learn some crucial lessons about star evolution by being able to witness the death process of all red giants, including Betelgeuse. The nuclear fusion that powers the majority of stars in the cosmos eventually runs out, causing a star to go through a number of amazing celestial changes before dying. In a nuclear explosion, hydrogen, which makes up a star at birth, fuses with helium in the star's core due to gravity. The fusion process frequently produces a lot of heat and light energy. After traveling to the star's surface, this energy is released into space as a photon. Helium starts to combine with carbon to make carbon as the star ages, and its main fuel, hydrogen, runs out. Neon will eventually combine with carbon to create oxygen once the helium has been used up. When this occurs, energy is absorbed rather than released by the fusion of neon and oxygen. When oxygen starts to fuse, the star collapses on itself, resulting in a supernova explosion because there is nothing to counteract the star's incredibly high gravity. One of the most powerful forces in nature, a supernova can generate more energy than 10 billion suns. Depending on what stage of their heavenly development they have reached, stars change color during the course of their lives, moving from the youngest, hottest blue structures to the older, cooler red forms. In 168 AD, the Greek scholar Ptolemy oddly described the color of Betelgeuse as having a bronze tone. It is possible that Betelgeuse was previously a yellow supergiant because 3 centuries ago, Chinese astronomers reported the star as having a yellow tint. Betelgeuse's blast could help astronomers better understand how red stars lose mass in the last few days before exploding in a spectacular supernova. As Dupree observes, this is the first time we've witnessed a big mass launch on a star's surface. We are left with a situation that we don't fully comprehend. We may directly observe this brand new phenomenon and use Hubble to discern surface features. Although it's uncertain if this evolution foretells Betelgeuse's upcoming supernova explosion, we're observing heavenly development in real time. NASA warns that although Betelgeuse is nearing the end of its existence, it may not have done so because the outcomes are so unexpected. In contrast, red supergiants die rapidly and vast time is long. NASA predicts that during the next 100,000 years, Betelgeuse will blow up. Significant research has been conducted on Betelgeuse since the 1st century BC, in order to determine how a star so big might behave over time. A researcher named Saran Nance and her team have more recently tried to determine the expected timing of the supernova explosions of red supergiants like Betelgeuse. Using Betelgeuse as a model, Nance and her team conducted a number of simulations before contrasting their results with field observations. Given that Betelgeuse is unlikely to explode for another 100,000 years, why did it abruptly darken, interfering with its normal cycle? Betelgeuse has been observed moving through the interstellar medium at a speed of more than 4 light-years wide after being ejected from its home in the Orion OB1 association, which contains the stars in Orion's belt. Betelgeuse began to decline sharply in October 2019 and lost 2.5 times as much brightness by mid-February 2020, falling from magnitude 0.5 to magnitude 1.7. By February 17, 2020, Betelgeuse had started to light up once more after maintaining a steady brightness for about 10 days. 5 days later, however, Betelgeuse appeared to have entirely stopped dimming, so bringing the dimming event to a close. It seems that the new visual fading was mostly insignificant because the infrared did not show any significant alterations on February 24, 2020. A research employing measurements at submillimeter frequencies ruled out a cloud of giant-grain circumstellar dust absorption as a major factor in the star's dimming, concluding that it was most likely the source. However, the dim, large star spots seem to be the cause of Ming. Subsequent analysis revealed that Betelgeuse's brightness dramatically increased from May to August. It is quite hard to observe Betelgeuse from Earth since it is so close to the Sun. According to Sounder satellite measurements, Betelgeuse had a brightness of 0.4 prior to 2020, when it was associated with the Sun. The star was 0.5 times fainter in June and July 2020 than when it was last observed on the ground in April. Since the maximum and next low were anticipated to occur in August and September 2020 and approximately April 2021, respectively, everyone was taken aback by this. Predictions were challenging because of the huge fluctuations in Betelgeuse's brightness. A second dimming event might happen far earlier than anticipated, based on the dimming. In June 2020, a second dust cloud was discovered emanating from Betelgeuse, which raised the possibility that the dust was caused by a cool region on its photosphere. The initial hypothesis that the dust was formed by the gas the star had ejected was validated in August by a second independent examination. Studies conducted in 2022 with the Hubble Space Telescope suggest that a surface mass ejection may have produced a dust storm. Thousands of kilometers away, the material was blasted from the star's surface, where it cooled, compacted, and created the fading dust of the star. About 3 times as huge as our moon, the damaged photosphere moved into space, cooled, and created a dust cloud that obscured the star from earthly observers. Even casual viewers who spotted the star's brightness shift could clearly see the fading, which started in late 2019 and continued for a few months. Even more unexpectedly, the supergiant's 400-day pulse rate has vanished. Astronomers have been monitoring this cycle since about 200 years ago by examining shifts in Betelgeuse's surface movements and fluctuations in brightness. The extent of the impact is revealed by its interruption. Cosmologists have recently come up with a plausible theory to account for the disruption. The photosphere is also healing, and the star is gradually but visibly regaining its strength. The interior of the star is vibrating like a struck bell, and its usual cycle is being lost. We have never observed such a huge star surface mass ejection. We still don't have a complete understanding of what is happening. In addition to using Hubble to view surface features, we might be able to directly observe this completely new occurrence. When will we be able to observe star evolution in real time? No one really knows, but it's unlikely to happen in our lives. Indeed, tomorrow or a million years from now might be the time. Will the supernova explosion from Betelgeuse destroy Earth? No, life on Earth won't be impacted or destroyed by the Betelgeuse blast since it will occur too far away. According to cosmologists, humanity would have to be within 50 light-years of a supernova for it to be dangerous. Betelgeuse is more than 10 times farther away. Instead, a very bright star in the evening sky will be viewed by everyone on Earth in a breathtakingly beautiful way. Finally, when Betelgeuse explodes as a supernova, astronomers will be able to observe the star because of its location. Don't go looking for Betelgeuse because it isn't visible in the night sky right now. Not much of it would be visible to us even if it bursts now. But in August, it's in the midday sky. Betelgeuse might have exploded already. In addition to being a prominent star in the Orion constellation, Betelgeuse, sometimes known as Scarabjuice, is crucial to the study of stellar evolution. Because of its size and special qualities, it is a great laboratory for learning about the life cycles of big stars. The star belongs to the class of red supergiants, which also includes some of the universe's biggest and brightest stars. According to observations, Betelgeuse might someday experience a major transformation that results in a spectacular supernova explosion. Depending on the amount of mass left behind after the explosion, this explosion is expected to produce a neutron star, or perhaps even a black hole. In order to better understand similar stars around the cosmos, experts are keen to collect additional data regarding its behavior, especially with regard to mass loss rates and surface changes. Apart from its scientific significance, Betelgeuse has also captivated the public's interest. Cultural allusions, like the iconic 1988 movie that bears the star's name, have solidified its position in popular culture. Interest in Betelgeuse is growing as it nears the conclusion of its life cycle, underscoring its importance from a scientific and artistic standpoint.